Hello, today we're going to be talking about tangent lines. First, let's go through some definitions. So a tangent line is any line that intersects a circle at only one point. And the point where that tangent line intersects with the circle is called the point of tangency. And a quick rule with any tangent line, a tangent line is always perpendicular to the radius of the circle at that point of tangency. So if we look at if we look at the circle I drew, we see that the line, where the line and the radius intersect, that is a right angle. A theorem that is commonly used when working with tangent lines is the two-tangent theorem, which is for any point outside of the circle, P, if two lines go through point P and are tangent to the circle, the two segments that are created are congruent. And we're going to prove this real quick. So we see that the two tangent lines create triangles OAP and OBP. And they both share the line OP and both share one side length, which is R, the radius. And since we know that the radius and the tangent line create a right angle, we can create a right triangle, where the legs are the radius, the BP or AP, and then the hypotenuse is OP, which we'll call X. So then from there we can make the equation R squared plus B squared equals X squared, and we see that both share R and X, so that for both triangles, B is going to have to be the same, and that makes these two triangles congruent. Okay, first let's work with regular tangent lines. Let's say we have a circle that's centered at the origin and has a tangent line where the point of tangency is at 1 squared root 3. And we want to find where what that equation for that tangent line is going to be. The first thing we have to do is find the equation for the radius that's perpendicular to the tangent line. And to do this, it's pretty easy since we know that it goes from the origin, 0, 0, to 1 squared root 3. So the slope is just going to be square root 3 over 1. And from that we can make the equation using point slope form, y minus 0 equals square root 3 times x minus 0, or simply y equals square root 3x. So from there, we can find the slope of the tangent line, because we know that it's just going to be the reciprocal of the other one. So the reciprocal is just going to be negative 1 over root 3, and then using point slope form, we can make the equation y minus square root 3 equals negative 1 over square root 3 times x minus 1. And that's the equation of the tangent line. So now let's try to use two-tangent line theorem to help us with solving a problem. So let's say a circle with radius r resides at the origin, and a point P, which resides at 0, 8, outside of the circle, has two tangent lines go through it, hitting at points A and B. If AP equals 6, so write that down, if AP equals 6, what is the origin angle for the arc length enclosed by the 2 points of tangency? So we know that AP is 6 and that OP is going to be 8 because it goes from 0, 0 to 0, 8. And we're going to need to find this angle. So using the two tangent line theorems, we know that BP is also going to be 6. And then from there, we're going to want to find this angle, which also using two tangent line theorem is going to be the same as this angle, because these two triangles are congruent, and we know that corresponding parts of congruent triangles are congruent. So next we're going to have to find that angle, and we're going to do that by creating this right triangle where the hypotenuse is 8 and one leg is 6, and it's right here because this is the right angle. And so from there we're going to do sine of x equals 6 over 8, or just x equals sine inverse of 6 over 8. Now we're going to move some of this, have some more space. So then from there, if we know that one of the angles is inverse sine of 6 over 8, since the other angle is also congruent, we can just do that times 2, and we'll get the origin angle, which is going to be 97.181 degrees. And that's how we use two tangent line theorem to solve another problem, and we see that the angle ended up being 97.181 degrees. Thank you for watching.